Okay, this is May 2015, paper 1, time zone 2, question number 12, and it's a section B question. So I'm going to do this in a few separate parts. Okay, the cubic equation has roots alpha, beta, and gamma. By expanding x minus alpha, x minus beta, x minus gamma, show that these things are true. So this is basically a proof of Viet's formula for a relatively small number, for power of 3. So I've got to expand out the right hand side here. Now by this stage you really should be able to expand out two brackets without error. So if you expand out those red brackets, you get x squared minus alpha x minus beta x plus alpha beta. And then we'll do the last bracket, x minus gamma. So let's look at the x cubed terms to start with. X cubed comes from here and here. That's just going to be x cubed, like we'd expect. And let's look at the x squared terms. They come from two places. They come from here, x squared times minus gamma. So we get minus gamma x squared. But I also get each of these times x. So it gives me minus alpha x minus beta x, and you can already see the symmetry there, x squareds, in that we've got alpha x minus alpha x squared minus beta x squared minus gamma x squared. Let's have a look at a different bit. So how do we get x terms? Well, we get x terms in two ways, from alpha beta multiplied by x, so that's positive, alpha beta x, and also from these terms multiplied by minus gamma, which gives me positive alpha gamma x and positive beta gamma x. And then constant terms. Where do constant terms come from? Well, only one place. They come from multiplying this by this, which gives me minus alpha beta gamma. And then it's basically an exercise in comparing coefficients. If you look at the purple ones, for example, the x squared coefficients must be equal to p. So I can write p equals minus alpha minus beta minus gamma. If you look at the green ones, they must be equal to q. So that gives me q is equal to alpha beta plus alpha gamma plus beta gamma as required, and the orange ones must be equal to c. So that gives me c is equal to minus alpha beta gamma. Done. Okay, for part B, we're given values for p and q, and we're told that the roots form an arithmetic sequence, show that one of the roots is 2. So we've got our results from before, that the roots, and these are just Viet's formulas, alpha plus beta plus gamma must be equal to minus 6, so 6. Now if they form an arithmetic sequence, which I'll call u1 plus u1 plus d plus u1 plus 2d, or 3u1 plus 3d must be equal to 6, which gives me u1 plus d is equal to 2, and that's the second term in the sequence. So part 2, hence determine the value of C, and we still have this 18 to use. We've still got the fact that if you add the products up pairwise, alpha beta plus beta gamma plus alpha gamma, then you get 18. And again, we can replace alpha with U1. Alpha is U1 and gamma is U1 plus 2D. And what we're going to end up with is a pair of equations, one from here and one from here, that we should be able to solve simultaneously. So let's do that substitution. We've got alpha is U1, so this becomes U1 times U1 plus D, alpha beta plus U1 times U1 plus 2D for alpha gamma. I know I've messed up the order there, plus U1 plus D times U1 plus 2D. And now it's just straightforward algebraic manipulation. Right mess this now, isn't it? So that's black line is equal to 18, and we've still got this little bit here, U1 plus D is equal to 2. So we're just going to solve that system, and we should be able to figure out a value for U1 and D and for alpha and for gamma and for beta and be able to work out C. So let's see, we get U1 squared plus U1D plus U1 squared plus 2U1D plus U1 squared plus 3U1D plus 2D squared equals 18. Collect that together. I've got 3U1 squared plus 1, 2, 3, 4, 5, 6 U1D plus what's left? So I've got the U1 squared done, plus 2D squared plus 2D squared equals 18. So it's a non-linear simultaneous equation. So let's use the fact up here that what's going to be easier to eliminate, much from much distance. The D is equal to U1, 2 minus U1. 2 minus U1. So we're going to eliminate D. We get 3U1 squared plus 6U1 times 2 minus U1 plus 2 times 2 minus U1 squared equals 18. So it's just a case of solving this now. Can I get rid of that? Yeah. And then we can go back and figure out what C is. We can figure out alpha, beta, gamma, we can figure out C, and we'll be done. So this is 3U1 squared plus 12U1 minus 6U1 squared plus 2 lots of 2 minus U1 squared. 2 minus U1 squared we can do in our head. 4 times 2 is 8. Minus 4U1 times 2 is minus 8U1. Plus U1 squared times 2 is 2U1 squared. For a total of 3 plus 2 is 5 minus 6 is minus 1. 12U1 minus 8U1 is 4. U1, oops, plus. And then Got plus 8 is equal to 18, is minus 10 equals 0. Or, getting rid of the negatives, plus 10 equals 0. So I can solve that for u1. You'll remember that u1 is, oh, not moving around any. You remember u1 is alpha, is one of the roots. So u1 is equal to minus b, 4 plus or minus the square root of b squared 16 minus 4ac, which is 40 all over 2. You'll notice it's a complex root. 4 plus or minus the square root of 16 minus 4 is 24, minus 24 over 2. Now there's two roots there, positive one and a negative one. Alpha, beta, gamma form an arithmetic sequence. Now that arithmetic sequence could be going up from alpha to beta to gamma, it could be going down. In fact, alpha, beta and gamma they're not ordered really. They're interchangeable what order they are in. So those two roots, 4 plus or minus the square root of minus 24 over 2, that's the two possibilities for alpha and gamma, essentially. And beta, this third root we already showed, was 2. So we've got alpha equals, without loss of generality, 4 minus, let's say, the square root of minus 24 over 2, which I guess we can simplify actually to 2, 8 minus 3i. Beta is 2, and gamma is the conjugate, 2 plus 3i. And actually, when you think about it, we know that if you've got real valued polynomials with complex roots, but real coefficients, then the two complex roots must be conjugates of each other. So c is equal to minus alpha, beta, gamma, which is minus 2 times 2 minus 3i times 2 plus 3i, which is minus 2 times 4 minus 6i plus 6i plus 9, which is minus 26. Okay, part C, similar sort of question. In another case, the roots form a geometric sequence, determine the value of C. So this time, instead of u1, u1r, u1 plus d, u1 plus c, we can rewrite things as, so we've got the same relationships, right? We've got alpha plus beta plus gamma equals 6, and alpha beta plus alpha gamma plus beta gamma equals 18. And we can rewrite alpha, beta and gamma in terms of u1 and r. And then we'll have two equations, two unknowns, u1 and r. We should be able to solve for u1 and r and figure out the value of c, which is alpha, beta, gamma, minus alpha, beta, gamma. So we've got, in the first one, u1 plus u1r plus u1r squared equals 6. And here we've got u1 times u1r plus u1 times u1r squared plus u1r times u1r squared equals 18. So you can see this blue one's going to simplify. u1 squared plus u1 squared r squared plus u1 squared r cubed equals 18. I've forgotten the r there. Two equations, two unknowns. The question is, can we solve this relatively easily? Let's look at the blue one again. We can take out some factors. u1 r times, sorry, u1 squared times, what will be left, 1 plus r plus r squared equals 18. And now let's look at the red one. We can do something similar. Take u1 out as a factor. You've got 1 plus r squared equals 6. And you may notice that there's some similarity there. 1 plus r squared appears in both, so let's divide the red by the green. What's highlighted in yellow is going to cancel, and we're left with u1 r squared r over u1 equals 18 over 6. u1 squared over u1 squared r over u1 just gives you, well, I was hoping it would be nicer than that. I guess it still works. Gives you u1r equals 3. Now it may look like we haven't achieved much there because we've still got two unknowns, but remember what we're trying to aim for. We're trying to aim for C, which is minus alpha, beta, gamma, or minus u1 times u1r times u1r squared, or minus u1 cubed r cubed. Or to put it even more explicitly, it's minus u1r cubed, which is minus, from here, 3 cubed, which is minus 27.